66. And all we need to do now is to put that into the calculator. So do we have no sound on that? Do we have sound?
No, yeah.
We do, or did we have no sound?
We didn't have sound, now we do.
Right, so I can start. Okay, we had a little problem with sound there. So we're looking at some trigonometry. We're looking at non-right angle triangles, and we're looking at this to try and find the area of the triangle. Right, so area of triangle is a half AB sine C, and we've got here a triangle of size 6, 7, angle 66. Let's look at this in the calculator. So with my calculator, I can put in a half times 6 times 7 times the sine of my angle, which here is 66, and we put in and we get an answer of 19.18. And if we go there, I can probably round that to 19.2 centimeters squared. Let's have a look at another one just to see how it goes. Maybe I've got a triangle which is obtuse. Let's have some sides, 5, 6, and this angle is going to be, let's say, 110. Exactly the same way. We work out half times side A, which is going to be 6, side B, which is going to be 5, times the sine of 110. We can do some calculations on this beforehand if we want to, just to say 6 5s are 30, times a half is going to be 15, times the sine of 110. This is just to make my life easier putting it into the calculator. And so in the calculator, then I've simply got 15 times the sine of 110. And that gives me the answer of 14.09, 14.1 centimeters squared. Some of these come with much nastier problems. And one of the problems that I know that comes up a lot is to have a look at a circle. Not very good at drawing my circles, but what they ask maybe is we've got this particular shape here, and we've got a sector, and they ask, all right, can you find the area of this little bit? I'll shade in the bit that we want. And what do we know? We know that this has a radius of 8, and we're told that this angle is perhaps, I know, 48 degrees. My drawings are never to scale. If I want to work out then the area of that, we need to work out first the area of the sector. To work out the area of the sector, this is the area of the circle, which is going to be pi r squared, times how much of the circle, and we've got 48 360ths. The r squared is easy because that is 8 squared, and so I can go and work out this fairly easy on the calculator. Let's just do that. So what we've got is my 48 over by 360, and I'm going to times that by pi, shift pi, and I'm going to times that by my radius, which is 8 squared. Let's get the number, and that gives me 26.8. Now, there is more digits. There are more digits. So what I would do on my calculator is I would typically store that in one of the memories so that when I want to use the value, I'm going to use the full digits on the calculator. Now, to work out the area of the triangle, and here it's going to be a half AB sine C. So let's do that, which is going to be, both sides are going to be 8. So we've got a half of 8 times 8 times the sine of 48. Let's do that. So I can do this largely in my head, but we're going to do it this way just for being complete. And then I'm going to times by the sine of 48. And there we've got 23.78. So now easily we can work out the area of the difference, and the difference is going to be my 26.8 minus my 23.8, and that's going to give me, if we do it on the calculator, I've got my memory recall, so I'm going to take my 26, so let's shift recall memory A minus my answer, which is going to give me here 3.027, and we can decide at this point that I'm going to round that to 3. So that's working out areas. They're not really that difficult, but there's more to these triangles than just working out the areas. And let's have a look at the sine rule. The sine rule is not that difficult, but it appears to be a bit more difficult because there are 2 of them. We can either have A over the sine of A equals B over the sine of B. And we use this when we're working out sides. Or I can flip this. I can have the sine of A over A equals the sine of B over B. And we can do this for working out angles. Let's have a look at trying to work out a side. So to work out a side, then what I've probably got in a triangle are two angles. Let's just draw in a grotty triangle, and we'll call this one 38, let's say, and we'll have this one as 70, and I've got a side which we'll have as 12. So can we work out what this is? So we're going to label our sides. So this is going to be side A, this is going to be side B, this will be angle A, and this will be angle B. So we're going to work out a side. So I'm going to use A over the sine of A equals B over the sine of B. Let's put those in. A over the sine of A, which is 38, equals B, which is 12, over the sine of 70. I want to rearrange this formula so that A is the subject. So I'm going to multiply both sides by the sine of 38. So if I put sine of 38 on both of those, these will cancel. And so we've got A equals 12 times the sine of 38 divided by the sine of 70. Let's go to the calculator and work this one out. So we've got a fraction, we've got 12, I have a problem with my mouse, times the sine of 38 all divided by the sine of 70. And it gives me 7.86 as the length of my side. 7.862, and I'm going to call that 7.86 to 2 decimal places. Not that bad to try and work out one of those. Let's do a different one. Let's see what we can do. This time I'll choose a triangle which is an obtuse triangle, just trying to prove that it doesn't really matter. And we'll have this side as 15. This angle can be 50, and this angle, oh, let's make it easy, let's have 100. And I want to work out the length of this side down here. You can see the sine rule's only going to work if we've always got something which is opposite to the angles, and this tells us what we're going to try and do. So we've got A over sine A equals B over sine B. I want to find this side, so this is going to be my side A, and I've got a problem, because if this is my side A, then I need to have this as my angle A. And if I've got 15 here, well, we've got to try and work out what's going to work so I can actually get anything going. So I could work out this side, if I only knew that angle, but I do, because my triangle equals 180 degrees. And if this is then 50 and 100, then my angle here is going to be 30 degrees. And now we can do something, because we have my side that I'm trying to find, A, over the sine of 30 equals B, which is in this case 15, over the sine of 100. Rearrange this formula. A equals 15 times the sine of 30, all divided by the sine of 100. Let's see if we can work that out over on the calculator. So on my calculator, let's put in this little formula. I find it easier to put the fraction sign in first. 15 times the sine of 30. And that is over the sine of 100. Yep, that failed, didn't it? I didn't notice that I didn't get that button pressed properly. The sine of 100. Things don't go well when they're going live, like not having a microphone on at the start for technical reasons. Right, let's press our answer, and there we have it. 7.615, which is going to give me 7.62 centimeters for its length. So that's the sine rule, having a look at a couple, and that one with something a little bit nastier thrown in. Let's have a look and try our charms at looking at the sine rule, but this time with angles. So I want to try and use the sine rule to calculate an angle. So let's have another triangle, and let's have here a couple of sides. So I'm going to have 9, I'm going to have 8, and we'll have an angle up here, which will have 72. And I want to work out angle X. We can use the sine rule in the same way as before, but it's easier if it's turned upside down. So we know that the sine of X over its opposite, over in this case 8, equals the sine of 72 over 9. Let's rearrange this formula to make sine x to make sine x basically the subject of this formula. Lost the word there. And I'm going to multiply this by 8 times the sine of 72 divided by 9. Because I'm working out an angle, then I'm going to use sine minus 1. So it's going to be sine of that is going to be all of that. Let's go over to the calculator and do that. So I've got in my formula 8 times the sine of 72. I could do this all in one go. I'm deliberately not. Over 9. And that's going to give me an answer. That isn't the answer I need, because as yet I've got to convert that. So we now know that the sine minus 1 of 0.845 blah blah blah, and that's what we're going to work out next. So I'm going to do shift sine of my answer, and that gives me the angle that we want, which is 57.7 degrees. And I've done that just to one decimal place. Often for angles, we only do this to one decimal place. Why? Because it's basically as accurate as you could probably measure it. I'll look at an obtuse angle. Let's suppose this side is 20. This angle will have as 105, and this side can be 7. And what I'm asked to work out is, can we work out this particular angle? So we've got everything matching, so there's no problem here, so that I can say my sine of my angle C over 7 equals the sine of 105 over 20. Rearrange this formula. The sine of my angle, so sine minus 1 of 7 times the sine of 105 over 20. I've written this all in one go. Let's work it out all in one go. Go to the calculator, and I simply want to find sine minus 1 of this particular fraction, which is going to be 7 times the sine of 105, all divided by 20. I'm going to close my brackets. I like doing that so it looks right, so you can see what it's right, but often the calculator will cope if you don't do that. And that gives me an answer straight away of 19.759, and that to one decimal place is going to give me 19.8 degrees. Sine rule. We've done then a couple of examples there. Hopefully you might have got the idea about how that works. So there's another rule, and this one is the cosine rule. And we often use these all together. Cosine rule, we have to sort of learn quite a nasty rule for this. So let's have a look at this one. Right, the cosine rule is basically that my side a squared equals b squared plus c squared. Now, this looks already familiar to you, hopefully, because this is Pythagoras, and we've got this extra little bit because it's a non-right angle triangle, so we're going to minus twice BC times by cos of A. let's look at a triangle to do this. Let's suppose this angle is 36. Let's have some sides. This is going to be 12. This is going to be 10. And I want to work out what the length of side A is going to be. Okay, so let's see what we've got. So A squared, and this is the one that is a killer for students because they forget that it's A squared. A squared equals B squared, which is going to be, we'll choose our side, B and C. So that's going to be 10 squared plus 12 squared minus 2 times 10 times 12 times the sine of 36. A is going to equal the square root of my answer. Let's go and put this into the calculator and work it out. So I've got my A squared, and we're going to just work out what that is. I could put square root around the whole of it to start with, but we're not. So I've got 10 squared plus 12 squared minus, and I'm going to put brackets around this so the calculator is happy to know that it's going to do 2 times 10 times 12 times, this time it's the cos of 36. And I'm going to close my brackets twice. And there's my answer. We need to square root this answer. And to square root it, then square root answer. And it gives me 7.059. And I'm going to round that to be approximately 7 centimeters. Let's do another one. This time, let's choose an obtuse angle. My triangles haven't gone well today for drawing them, but still. So let's choose perhaps 135 degrees. And this side's going to be 7, and this side's going to be 5. And I want to work out what the length of that side is going to be. Let's do it all in one go this time. So my angle X is going to equal the square root of all this equation, which is going to be 7 squared plus 5 squared minus 2 times 7 times 5 times the cos of 135. Let's go and put that into the calculator and see what happens. So my number is going to be the square root of, then 7 squared plus 5 squared minus 2 times 7 times 5 times the cos of 135. And that gives me a length of 11.11. And I'm going to just call that 11.1. Can we use the cosine rule to calculate an angle? Unfortunately, the answer to that one is yes. And because it is so, we need a new formula. The cos of my angle A is going to equal B squared plus C squared minus A squared, all divided by 2BC. Let's have a triangle to try and work this out. And we'll look at a nasty triangle here. This side's 11, this one's going to be 13, and this one's going to be 16. Let's see what we can work out. And I'm going to work out this particular angle. Right, just dealing with a phone call coming in. Right, okay, so let's see if we can work out what we've got. Now, we've got here simply to work this one out. So we've got my formula up there, and that's going to be then the cos of my angle A is going to equal 11 squared plus 16 squared minus 13 squared, all divided by 2 times 11 times 16. We're going to do this in 2 stages. So let's go and put this into the calculator, and we'll see what we've got. I've got my numbers then. 11 squared plus 16 squared minus 13 squared, all divided by 2BC, which is going to be 2 times 11 times 16. And that's going to give me the answer of 13/22, and that's going to give me here that as a number, which is 0.5909, and that is what my cos of A is going to equal. So all I need to do now is to do the cos of that, and to find an angle we use shift cos of my answer, and that gives me my angle, which is,
I don't know that one.
53.77, or I'm going to do that to 1 decimal place, 53.8 degrees. And I'm happy that I can beat the Alexa device. Right. Could we do this if we had a different shaped angle, an obtuse angle? Of course we can. Let's look at this as an obtuse angle. I've got an angle here, X, that we want to try and work out. This side's going to be 7, this one's going to be 9, and this one's going to be 13. I want to work out angle X again. So the cos of angle X, and we'll do this one all in one go this time. So I'm going to do cos the -1 to work this out of all of this, which is going to be my two sides here. So I'm going to have 9 squared plus 7 squared minus 13 squared, all divided by 2 times 9 times 7. We'll go to the calculator and we'll try and work this out. So I'm going to do shift cos to the -1 of this particular equation, which is going to be 9 squared plus 7 squared minus 13 squared, all divided by 2 times 9 times 7. I'm going to close my bracket, and if I work this out, we come up with the answer of 108 degrees 0.03, which I'm going to call 108 degrees. And there is my answer. We've met several things then. We've met the cos rule, the sine rule, and the area rule, half AB sine C. We use these in combination. The hard bit of trying to do these in combination is really trying to work out, is this going to be a sine rule or is this going to be a cosine rule? And generally, this is relatively easy to work out. But that's up to you to try and solve your problem. Thanks for watching. If you found this useful, then please subscribe. And I'll see you same time next week, and we'll have a look at some more difficult maths problems. Until then, stay safe. Bye-bye.